Hello and welcome to C++ Weekly. I'm your host, Jason Turner. Yeah, I just really want to start this episode by giving a huge shout out to all the people who have supported and given thumbs up and commented, and my patrons and t-shirt buyers and book buyers and all of you who really help keep this channel moving. It just would not be the same if I was shouting into a void. In this episode, I want to talk about standard array, and I'm going to show a simple implementation of standard array. So be sure you stick around. Now, I want to start with the fact that this is not going to be a 100% complete standards compliant implementation, but hopefully we can get pretty far into it. I would like to at least see ranged for loops working and possibly see structured bindings working when we're done with this. But I really just want to point out a few things. First of all, the array class conceptually is very simple. It exists so that we have a strongly typed way of accessing arrays. C arrays are terrible in that they implicitly convert to pointers if you look at them sideways, and a C++ class or struct does not do that. Now, I am actually intentionally starting with this as a struct, and that will make sense in just a moment. So this is a templated type. And if we were going to create one of these, we are going to look something like, we want an array of tenants. Yay. Now, if you know anything about standard array, this thing is an array of 10 uninitialized integers. I'm going to go ahead and dial this back to 5. It's an array of 5 uninitialized integers. If I return one of these values, that is an uninitialized value. But let's go ahead and actually make this compile. So we have the contained type, and we have the size. Simple as far as templates go. Now, what is actually in here? We have some sort of data element. I'm just going to call it data at the moment. Now let's call it values. Values sounds good to me. And it is of type contained, and it is a C array of size. Well, this doesn't compile because I don't have size t available yet. Let's go ahead and get the right include for that. Okay, so interestingly, this first line of code compiles. This one does not. So we need to give some sort of index operator access. I'm actually getting data is used uninitialized here. The compiler's smart about this. It knows that I'm trying to return an uninitialized value. Thank you, compiler. So let's go ahead and give this some values. Now, this is the very first strong point that I want to make about standard array. Standard array has no constructors. You can go and dig into the CBP reference documentation yourself if you would like. It has no constructors. It is required to do direct initialization. This is one of the reasons it can be considerably more efficient than something like a vector can be, besides the fact that it is all stack allocation. So I have passed it 5 integers, and I have directly initialized this thing. Now, you might note that when you're using standard array, you don't have a .values object that you could just poke right into like we do here. Well, you don't think that you do anyhow. Let's take a little peek behind the curtain. All right, it has no member named values. Let's see. No. Let's try that. Unresolved overloaded function type for array subscript. That's because data is a member function. Okay, we are down here in the array implementation of lib stood C++ because that is the version that we are currently using. All right, we can see all of these references to underscore capital M underscore elms. Okay, there we go. That worked. And surprisingly, we have just stepped into the land of undefined behavior because the standard library has reserved for itself anything that begins with an underscore followed by a capital letter. As the rules are complicated, this is a identifier that is reserved by the standard library implementers for themselves. We are not allowed to know this exists. If I were to mess with this, the standard library could come back tomorrow and decide to change it to this and say, haha, we broke your code. And they're totally allowed to do that. But the point is that there is a public C array inside standard array. So we have to do the exact same thing. But we are required to leave ours accessible because if I were to come back and try to do this, I am now myself in the realm of undefined behavior because again, this is reserved by the standard library implementation for itself. That's probably a little annoying to some of you. Let's just go ahead and call it underscore values and pretend like it's hidden, I guess, because that's the best that we can get with our version of array. Now, if you were looking at that code as we were scrolling through it, a considerable amount of the standard array implementation goes something like this. Okay, we've just created a perfectly valid begin and end functions, but we only have the non-const versions of them. So let's go ahead and add the const versions. And now we only have the ones that aren't explicitly named cBegin or cEnd. So let's go ahead and add those. And on it goes. They are all very simple accessors. They are just over and over again the same simple kind of things. Let's go ahead and scroll back through this. Data just returns elem, and there's const and non-const versions of it. Back returns the elems with the number -1, okay? And there's so many implementations of back and front and at that are all almost identical. And you have the index operator overloads and empty, which is just, well, that should, well, I don't know why they implemented it like that. I would have done underscore nm equals 0 because the size is fixed at compile time for empty, but whatever. We're basically done at this point from the perspective of this episode of C++ Weekly, because now we can do a ranged for loop. Yep, so we printed 2, 3, 4, 5, 6, exactly as expected. And so now I'm going to attempt the structured binding, but I have to actually provide the tuple size and tuple elem structured binding hooks into the standard library. We can kind of just cheat and copy the implementation that's on CVP reference. And I can place this right into the standard namespace without having to actually open standard namespace, which is the correct way to do this. I don't want to redefine that. I'm doing it for my array. But this just tells the compiler at compile time how many elements this thing decomposes into. And now I need to provide the tuple element access. So this is just letting the compiler know what the element type is for each element in the tuple. Now, fortunately, in an array, all the elements have the same type. So that's easy. It's just always returning the same type back. And now we need to provide the getter, which I'm not going to provide a fully complete implementation of the get because I need to provide like 4 of them if I was going to do that. So we're just going to provide the const version of it. Okay, there you have it. 2 plus 3 plus 4 plus 5 plus 6 is apparently equal to 20. That is the last print statement here. So that's, again, pretty much sums it up. The points that I wanted to make are that it is a very simple struct with a public, although illegal to access, values. The accessors are all pretty straightforward. And then you need a few hooks into the standard library for structured bindings to work, but then you have standard array. Of the standard container types, it is quite simple. So thank you again for watching this episode of C++ Weekly.